Well, Surgeon Dr. Ahmad Gilani is there, and today I am here to simplify the concepts of the fluids and electrolytes on a surgical floor. I will discuss the practical implications. I will not discuss about the boring too much detailed theoretical aspects. So let's start. So first of all, this slide is very much compulsory whenever you discuss the fluids and the electrolytes. And remember always, the water gain will be equal to the water loss. So from where you gain the water? You gain water from the metabolic water, that's the 200 ml. You ingest food and it contains the water 700 ml. And you ingest also liquids and it contains 1600 ml of the water. So the water losses, it is lost in the form of GIT tract, especially in the stools, almost 100 ml. Then it's lost from the lungs through respiration, that's the 300 ml. And from the skin, 600 ml is lost per 24 hours. And from the kidneys in the form of urine, it is lost almost 1500. So this is the urine, this is the stool, and this loss is the insensible loss. Okay, so the water gain should be equal to the water loss. This is the very basic concept. So on the surgical floor, you give the maintenance fluids, and the maintenance fluids, they are those which when administered they maintain the urine output up to 0.5 to the 1 ml per kg per hour. So approximately for a 70 kg person, it becomes 40 ml per kg per hour for a 70 kg person. Okay, and this thing you will remember, and it will be helpful in the next sections of our slides. So moving towards the next slide, whenever you talk about the maintenance fluids, you will also talk about the electrolytes. And most common electrolytes which we talk about, that's the sodium, that's the 1 millimole per kg per day, and potassium also 1 millimole per kg per day. You have to replace it, you have to maintain, that's the maintenance fluid. Then you will also talk about the dextrose, there it will be 100 to 150 gram per day. And this is very small amount. What you say, it will provide nutrition? No, definitely it will not provide nutrition. It's for the brain. And summarizing the things, the maintenance fluid will be equal to total intake is equal to total output, and total output, it's in the form of stool, urine, and insensible water losses. So moving towards the next slide, electrolyte deficit. So you have got two methods to calculate the electrolytes deficit. First method is the formula method, which is the accurate method, and other method is secretion losses, and I will discuss that's to somehow it's a crude method. So first of all, we are going to discuss about the formula method. So to calculate the sodium deficit, you will use the formula total body water multiply weight in kg multiply by the sodium desired minus sodium measured from the serum electrolytes, and total body water in male it's 0.6, in females its value is 0.5. So it will not make a lot of difference, so you can use both of the values. In the same way, the potassium's deficit, it will be equal to 0.6, that's the total body water, multiply the body water in kg, and multiply by potassium desired minus potassium measured from your lab values. So this is the formula which you have to remember. In case of potassium, sometimes we also use 0.4 instead of 0.6. So this does not makes a lot of difference. So don't be conscious about this thing. So moving towards the next slide, we are going to calculate the electrolytes deficit, and now we are calculating this sodium deficit. Here you can easily see that the formula is total body water multiplied weight in kg multiplied by sodium desired minus sodium iode. So almost it will come 0.6, that's the total body water, that's the constant value. 70 kg, it's the weight of the patient, and our desired value of the sodium is 140 minus the calculated sodium, that's the 133. It will be from the lab values. You have to calculate this thing, and when we are using the calculator to calculate these values, it will become the 252 millimole, that's the sodium deficit. So to make the sodium from 133 to 140, which is our desired value, we have to give 252 millimole of the sodium. So that's the sodium deficit. In the same way, we are moving towards the next slide. In the same way, we have explained the calculation of the potassium deficit, sorry to say. Again, total body water, that's the 0.6, then body weight in kg, and then potassium desired minus potassium iode. So putting the values in a 70 kg person, for it's our desired value, and 3.1 suppose it's our calculated value, and putting the values and using the calculator, and it will become 37.8 millimole. So you have to use 2 ampoules of the potassium to fulfill this deficit. Now moving towards the next slide, and we can also use the crude method, that's the secretion method. Suppose I have put the Ng in the patient, and he has lost 1 liter. Definitely in the Ng only 2 things will be there. One thing is saliva, other thing is the gastric juice, and definitely if we calculate the 70 plus 15, so the patient will lose 85 milliquintal of the sodium if he has lost 1 liter in the Ng. And meanwhile, in the same way, you can calculate the other values also. So this was very simplified way to give to the concept that how we can calculate these deficit with the help of secretion method. So you can memorize this table. So now this is the most important slide, the composition of the various IV fluids. So you must have on the fingertips. Most of the times Hartmann and Ringer it's considered as same, but there is slight difference, like the sodium content it's 131 in the Hartmann and 130 in the Ringer lactate. Same way potassium it's 5 in the Hartmann, and in the Ringer lactate it's 4, and calcium it's 2 in the Hartmann solution, and in the Ringer lactate it's 1.4, chloride 111 in the Hartmann and 109 in the Ringer lactate, and lactate component it's 29 in the Hartmann and 28 in the Ringer lactate. So you can consider these fluids as the same fluid because there is very slight difference in their composition, but in the normal saline you will find only 2 things, 154 sodium and 154 chloride, and 5% dextrose. It will contain only 50 gram of the dextrose in 1 liter, and Hemexal it will contain 145 sodium, 5.1 potassium, 6.26 calcium, and 145 chloride. So you must remember the composition of these fluids to solve different scenarios. So moving towards the next slide. So first slide, in which the pre-operative fluid management. Pre-operative fluid management, you will look for the three things. And what those things are there? If you are going to perform the laparotomy or any surgery, so you will definitely think about the three things. First is the HB, second is the hydration status, and third is the electrolytes. And it should be corrected before surgery whenever possible to optimize the patient. And in case of the HB, if you are transfusing the packed cell, it will raise the HP by 0.8 to 1 gram per DL in a 70 kg patient. And the hydration status, you will monitor with the CVP. That's the accurate method. And the another method, that's the urine output. You will put the Foley's catheter and you will monitor the urine output per hourly. In case of electrolytes, the same formula which I have discussed in a previous slides, you will use it. That's the total body water, multiply the water in kg and into desired sodium. In the previous slide, I have used the value 140, and the patient sodium by the serum electrolytes, which will you calculate. That in the previous slide I have used the 131. And total body water 0.6 for males and 0.5 for the females, so it will not make a lot of difference. Meanwhile, you have to calculate the potassium deficit and you have to replace accordingly. So moving towards the next slide. Then you have got the intraoperative fluid management. You might be thinking, most of the time we are doing the surgeries and we don't bother about the intraoperative fluid management. So it's the task of the anesthetist. So you will see this in the anesthesia notes. Definitely you will use the maintenance fluids and blood loss. 1 ml blood or a colloid per 1 ml loss or 3 ml crystallite per 1 ml blood loss. So if you are using the colloids, then 1 is equal to 1, and if you are using the crystallites, then 3 is equal to 1. And you have also definitely calculate the third space losses, and you will replace these losses accordingly. And in case of the third space losses, we have simplified the things, that if incision is small, the patient will loss 1 to 3 ml per kg per hour, and 3 to 7 ml per kg per hour for the moderate procedures like the medium incision, and 9 to 11 ml per kg per hour for the major procedures, and in which you have given the larger incisions like exploratory laparotomy. And you will also calculate the ongoing losses, like from the NG, stool, he is passing the stool, bile, and the pancreatic secretions. So intraoperative fluid management, you will look for these things very consciously.